Amigo will discuss JetBot, which has a Jetson Nano on it. It's a pretty cool project, and you're on the air.
All right. So I just wanted to start off with a demo. What you see here is a DIY robocar that's running a neural network for obstacle avoidance. And I'll go through the code for this, but all that the robot is doing is using the Raspberry Pi camera. It's been trained on about 1,000 images to identify what's an obstacle and what's not an obstacle. And the goal of this robot is to just avoid obstacles. But as a part of our training, we trained it on tables, so it now knows edges are obstacles that it should not cross over. I can put anything in front of it, and in real time, it's going to detect that's an obstacle. And I can take this robot off the table and put it down here on the ground, and if I go in front of it, it's going to. So this is, yeah. So it generalizes pretty well. You can train it on a good set of database, but so as you can see, it'll most likely not run into things. Yeah. All right. So I think for the rest of the part of my presentation, I'm going to turn this thing off, and I'll go a little bit into the technology that's running behind this. So give me a second to turn this off.
It's alive. Tabletop Challenge Phase 1.
Just for the video camera.
You're bringing that to RoboCon.
Oh! That's because I turned it off.
Let's see if we can pass Phase 4. You can fall off his belt for Phase 4. Does it still run?
Yeah, it'll still run.
We need to see that.
Fortunately, nobody cares.
No. So you see, what I did there was just I did the unobserved for the camera class, so the robot stopped getting the data from the camera, and as a result, it's just stopped there. And all the programming that I was showing running on the robot was actually being done with the Python notebook.
It's being done with what?
So all the code is written in Python. So and everything is done using Jupyter notebooks. And okay. So this is the JetBot that I was just demonstrating. When we started working on Jetson Nano, our goal was to make a computer that's going to enable makers, learners, teachers to all easily learn and develop AI-based solutions. And so it starts with the computer that we built, which is Jetson Nano. But in order to really show what it's capable of, we wanted to make a platform, a DIY platform that was open source that people can, take away and start developing on. So JetBot is, we have the entire software stack for this, as well as the hardware. The chassis is 3D printed. The bill of material, everything is available online on our on GitHub. So if you go, we've got pretty detailed instructions on how to set up the hardware from. Is it not sharing? So this is the website which is on GitHub, where we have the detailed instruction on how you can print your own chassis, connect everything, and build this robot. And the most important part of it is the software that's running on it. And our goal, again, was to bring it to anybody who wants to get started with AI, anybody who wants to get started with robots should be able to do this. So we went to the route of creating the entire software stack through Python notebooks. And as I was showing you earlier, this is where I was running the code from. It's all the camera was streaming the data into my browser. All that you need to program this is any laptop with the browser, and you're good to go. So coming back to the JetBot, we have provided, the idea with JetBot is it's a reference application that we've built. We have provided some initial neural networks for things like, as you saw, the collision avoidance. What Rohan showed, the object following, that's another thing that's available. And the whole idea of the software stack is not just to give you working examples, but to make it more like a tutorial. So as you go through the notebooks, you would feel, at the end of it, you would feel like you can build your own thing. That's our objective. And so we have the Python notebook for getting started. For people who are familiar with ROS, we are working on creating ROS nodes for models of the robot, and we will add perception and all those things as well as part of ROS nodes. That's work that's happening right now. And if you want to learn more, get into the details of this, we are having a webinar that you can go on developer.nvidia.com and register on May 6th, May 16th. Just to give you a quick idea of the demonstration that I was showing right now is based on what we call the collision avoidance notebook. And the whole idea was you take this camera, stream the video to your laptop, and just label it from the Python notebook what the robot should think is an obstacle and what it's not. So let me quickly play this video if it will work. Okay. So as you can see, you can just keep placing all kinds of things that you want the robot to learn. And there's a streaming video from the robot, and then there's going to be a widget at the bottom of which we will have two labels, which is blocked and not blocked. And as you keep putting things, as you keep placing the robot in different orientations, you can just say add free or add blocked, and it'll keep generating a database of images. The cool thing about Jetson Nano is that it's running the full Nvidia GPU. So you can buy a $10,000 machine that has an Nvidia GPU, or you can buy this $100 Jetson Nano. It's using the same Nvidia GPU architecture. It's using the same CUDA programming interface. As a result, you can not only just run inference on it, you can actually train the robot on it. So if you go to our GitHub, you can collect your own images. If you have a good beefy GPU and a good compute, you can train it in a matter of minutes. But if you want to train it on the robot itself, within an hour or so, you can train this robot to do this collision avoidance on your own data. If you see that this robot is falling off something that it's not trained on, just collect the data, retrain it on the robot, and deploy it. So a little bit detail about the developer kit that's running on this. So what you see on top of that is this Jetson Nano developer kit. It's priced at $100. The specs for it are here. As I mentioned, it's got a full Nvidia GPU, 128-core Maxwell GPU, 4 gigabytes of RAM, quad-core ARM CPU. And honestly, for people who've developed with something like a Raspberry Pi, which a lot of you here already have, this is the next step where you want to take it to you want to add AI, you want to add perception to your robots. This is the product that's the next step for you to graduate from Raspberry Pi and start doing something else. So this is the developer kit. It's available from a bunch of partners here. We expanded our channel because our idea with this product was to reach the bakers, to reach the community and developers. So we have added SparkFun and Seed Studio, and we are doing a lot of interesting projects with them. And so this is available now from all these partners of ours. In addition to the developer kit, this is the right time for AI-based mass market devices. So we saw a huge need for systems like small home robots or small NVRs today that are just generating the data and recording them, not doing anything with them. There's a huge need for all the video streaming data to be analyzed and processed. So underneath this developer kit, at the heart of this is a small module. It's a 260-pin SODIMM connector, and the developer kit comes with a module and the heatsink and the expansion board for it. So this is what a lot of our customers are using this to eventually build their own products based on this technology and take it to market. So this is your solution for production, and this is what you use for your development purposes. Yeah, so these are the details for the module. Another thing is the power consumption on this. So Jetson Nano, we have 2 configurable modes. As you see, there's a lot of computation available on it. A lot of applications do not need all that compute. So it's since it runs full Ubuntu Linux, all our software that we provide for Jetson is available with source. So you can control your clocks, you can control everything on the system. But we do provide 2 pre-configured modes which would run a typical application in the 5-watt mode or the 10-watt mode. So depending on what the thermal your product can tolerate, you can configure the product to operate in one of those 2 modes. Again, a few details of the module itself. As you may notice, we are providing a bunch of IOs on the developer kit, but it's not an exhaustive set of IOs that the module is capable of. An example being PCIe. So we've got PCIe lanes on this. We've got CSI. We've got 3 CSI by 4 lanes on it. But some of this is available on this carrier board. But if you look at the module by itself, it has a lot more IOs available, and it has a lot of compute available on it. Here are some of the commonly used networks that we ran on Jetson Nano, as well as a few other products that are out there today. And as I said, the fact that the Jetson Nano runs the full computer, full CUDA stack, you can run pretty much any framework that you want to run on this product. And we support a wide variety of network, whether it's pose estimation, whether it's classification, whether it's object detection, segmentation. You name it, and you can deploy it on this product. For those of you who haven't heard about Jetson, Jetson Nano is not the first product from Nvidia. It's actually our 6th Jetson product. We started off with Jetson TK1, which is not on the slide, which was only a developer kit. But since then, we have done Jetson TX1. We have 3 versions of Jetson TX2. One of them is a 4 gigabyte SKU and the 8 gigabyte SKU, and there's an industrial version which comes with a 10-year supply life. And the biggest and the beefiest one of that is Jetson AGX Xavier. So we have a family of products that goes from Jetson Nano with 0.5 teraflops all the way to Jetson Xavier, which offers you 30 teraops of performance in this form factor. On top of Jetson, all Jetson products run the same software stack. So that's if you start developing on Nano, you feel like you need more compute. All your software development work is not wasted. You can port all the applications that you develop onto TX2 and make use of the performance that's available. We start off from our board support package. Built on top of that is a full desktop class Ubuntu derived Linux system. Then we have our accelerated libraries for some of the areas that Jetson is used for, whether it's graphic or accelerated computing, computer vision. And further on top of that, for specific markets, for specific verticals where Jetson is being highly used, we are creating more vertical SDKs built on top of these libraries. And DeepStream is one of those SDKs that we've created for video analytics. And we recently, the slide is not updated, but we recently announced Isaac as well, which is our SDK for robotics. again, Jetson products support all kind of. It's an open framework support. We support all the popular frameworks. We support ROS, Docker. For IoT integration, we're working with AWS, Microsoft, and hopefully with Google soon. And so, the three pillars of Jetson are hardware, a software stack that Nvidia provides, and of course, when you want to go to production, you want to build products, you need a pretty solid ecosystem because computer is just the starting point. So we have a very solid ecosystem of hardware, software, distribution, and partners who can provide value-added services on top of the product. That's all I had. And so, as I mentioned initially about the JetBot, the key thing for us was to provide a software stack that will act as something that people can reuse and deploy it on their products. We were at the DIY Robocars. I think I see some of the familiar faces here who were there this weekend. So we took the same software stack, the same Python notebook that we showed running on the JetBot. The only thing we had to change was the motor class because this was running on a Traxxas base. So we had to change the motor class for a motor driver for that particular robot. We trained it on about 400 images for the track, and we said, let's give it a shot. And this is what it looked like. So the robot had
again showing typical. Oh, I think I missed. Did anyone see it hit?
So yeah, first time for us at DIY Robocars. Collected the data, not a single line of code written,
Nice.
No programming done, everything done with AI and deep learning. Alright. So I think that's all I had. This is a developer website, developer.nvidia.com. You can get started with Nano. That's a URL. And as I already showed you, the JetBot site on GitHub. Take any questions.
I'd like to, sometime in the future, hear a talk about Isaac.
Sure.
Just starting to look into it. And my personal wish list is that the Intel RealSense 265, T265 will work on this or the TX2. I have not successfully got it to work with the latest jetpack.
Yeah. So Intel RealSense is one of the sensors that a lot of our customers are using as well. We are working closely with the team that develops the product, and we will pretty soon see much better support from both Nvidia and the Intel team on that.
Excellent.
Across all the products. As part of Isaac, we did release another robot which is called Kaya. I don't know if any of you have seen it. It's a small robot with 3 holonomic wheels. With the full software stack is available on it. That one also runs on Jetson Nano. It's a DIY robot. It's slightly higher price point. I think the BOM for that is around $1,500. So that one uses the Intel RealSense D435, and we have the drivers for it. So if you want to get started, that's a good place to get started.
Do you have any club or maker or hacker discounts for
on Nano, I don't know if you guys noticed, the price of the developer kit is actually less than the price of the module, and that's a discount. Since we wanted to evangelize, we wanted to get the developer community to adopt this. We have already reduced the price on developer kit as much as we could.
How much is it?
It's $100. Oh. Yeah.
So Nvidia is a big company. Can you just say a few words about what your department or where you fit in?
Oh yeah, sure. I should have introduced myself. Thank you. So I'm the senior product manager. I've been at Nvidia for about 8 years. Started working at Nvidia on the sign-off side. So I led the sign-off methodology for about 24 processors at Nvidia, and then decided I wanted to do something more external-facing, so moved to the product team. And I've been managing the Jetson products for a little over 3.5 years. So launched 5 products. This is the latest one. And so my team is responsible for creating the Jetson product as well as doing the business development for it.
Wow.
I saw the robot doing the laps, but I didn't hear what the time track.
The time on that lap that we did was don't quote me on it, it was 10.9 or 11 seconds. We, when we were training the data, we got 8.5 seconds. When there was nobody around, we trained it. We have a video of that. We'll probably go back again. You know, our idea again was we'll make the software stack open source as well pretty soon for that. The images that we collected, the neural network that we trained, we'll make that available. Yeah, so we were able to do 8.59 seconds in a trial lab. But our goal there was just to see if it works, and it's just amazing to see how easily these things generalize. This table, this robot has never seen, you know, this carpet has never seen. It's just relying on vision and generalizing things.
So is that you guys have any plans to be even lower price Nano?
Nothing that I'm aware of today.
Because it's still kind of higher than the Raspberry Pi.
Yeah, I mean,
there's
Raspberry
a
Pi.
quantum difference here. He's talking about.
Yeah, I mean, you know, as I said, this is the next level from Raspberry Pi. This is not something that you would replace a Raspberry Pi. I think Raspberry Pi has a great value in the developer ecosystem for getting started. So this is the next level where, you know, we are putting in 128 cores GPU, 4 gigabytes of RAM. There's a lot more that's going into the system that's driving the price of it. And as you said, you know, there is Raspberry Pi, which is available at a lower price. And then, you know, if you want to do something to get started, that's a perfect place to get started with.
So are you going to plan to sell a chiplet one alone, or it has to be all this is so much?
No, and so the plan is to continue with the system and the module, and you know, big reason for that is the ecosystem. You know, the way we can foster this ecosystem and grow this ecosystem is by keeping this form factor and the design philosophy that we have. And the second most important thing is the software. The pace. I don't have a slide here. Every 6 months we are releasing a software update. So the latest version of CUDA and cuDNN that we are releasing for is going to be running on the TX1 that you purchased in 2016 as well. So over the years, we want to keep doing optimizations, keep improving the performance, keep improving the power of the product, and that's only possible if we can control, you know, the whole ecosystem and the product itself.
I guess follow on the earlier question. So, in other ways, say, is there any roadmap from the market development to increase performance or drive down price?
Well, at Nvidia, we are always thinking about increasing performance. That's our, you know, our never-ending goal. If you look at our embedded products, it's almost like a time machine. You know, we introduce first our newest architectures, newer products for our gaming business, which needs the highest performance. And over a period of time, we bring it down to all our other product lines, whether it's, you know, whether it's graphics, enterprise graphics, or whether it's the Jet's embedded form factor. So you can look at our roadmap on our discrete graphics and see how that's going to translate into our embedded form factor.
Yeah, I'm not sure if you addressed this, but you said that there was a Maxwell core.
Yeah.
Why is it on Maxwell and not the newer Pascal or Turing?
Pascal core is available on you know, TX2, and the Volta is available on Xavier. And in the future, of course, we will bring a product with Turing. So we do have products that they're just, you know, at different price points. And
so it was basically like a cost issue on the Nano.
Absolutely.
Okay.
Yeah.
That makes sense.
I noticed on one of the screens it said RTOS.
Yes.
What RTOS support do you have?
So
there it is, right there.
Yeah. So on the Jetson, some of the Jetson products, we have an ARM R5 a CPU in there, and pretty soon we will be releasing a free RTOS that runs on that R5 controller. Yes, it's
so
coming.
You don't have free RTOS for that ARM5 yet?
Yet, it's coming in a couple of months.
That's good. Well, that will also run on my TX2?
Absolutely. That's what I meant by the software upgrade. You know, we want to keep investing in software. That's our biggest investment.
So the TX2 is still supported?
Absolutely. Yeah. Everything on the product line, you know, all Jetson products, we are. Because we have a lot of big customers that are using this product, so we are committing to minimum 5 years of supply, and you know, beyond that, it depends on the opportunity. All right. Yes, that was it. Thank you very much.